Good morning, good afternoon, and good evening again, Mavi family. Yeah, we've had a busy few days. It's Friday, Monday, as well as Tuesday. So today, I just quickly, before I hand over to our guest presenter, Jeffrey Smith, which is the ARIIX Quality and Assurance Manager, I quickly just want to remind you of the rest of the trainings for this week. So today we've got the Puritii brand. Tomorrow we've got Fernando doing Slenderize, which as well as speaking about transformation. And then on Friday we've got the ex-office training with either Omar or Taylor. And I just want you to know, so for this week the webinar IDs are still the same, but for next week's, so for the last 3 of July, the webinar ID is changing. But I will communicate that out. So Monday, we've got ARIIX as well as Sincerity, and we have some of our top leaders that's going to join us there and speak about their transition. Then we're going to Wednesday, Nutrify, and then we've got Executive Note from Jeff Yates, and I'm sure that all of you heard today about the amazing news about the merger that was finally announced that we were waiting to find out who it is. We finally know it is a really, really good company that I've already researched before the time and know quite a bit about New Age. So, and as somebody said today, to weather these storms of these times that we're in, we need to have a big boat. And we are definitely part of a big boat. So without taking up any more of your time, I'm going to hand over to Jeffrey Smith. Hi, Jeffrey. How are you doing?
I'm doing very well, thanks. How are you, Lee?
I'm great. Thank you for joining us today. I'm just going to make you co-host so that you can share your screen.
Okay.
And then we can start.
All right. And I'm happy to be here with everybody again today. I apologize for the problems last week. I think I've gotten those sorted out. So we'll see what we can get through today. All right. I'm going to go through here and all right. I'm assuming everybody can see.
Yes, we can see your
Now.
screen.
Okay, great. Okay, there we go. I've got it, the presentation set up. So we will toggle back and forth between this slideshow and the white papers outlining our test data for the Puritii products. But this will be our primary, I guess our flow will be driven through this. So as we attempted to do last week, I'd like to go through, we have 4 products in the Puritii range right now that I'd like to discuss. Primarily of those 4, 3 products, because the 4th is not yet launched and it will be launching in Japan, and then further availability is yet to be determined. But we'll start with the Puritii air purification system. Then we'll go through the Puritii water purification system and the home detox. And then just a little bit reminder about the laundry detergent, but just because it is in the Puritii brand. But the Puritii brand was, it began as dealing with a way to combat the ever-increasing problems of air and water pollution that we find in our environment no matter where we live. Really, it's increasing throughout the world, and as I understand, the Puritii air purification system began in conjunction with Ian Chandler, who was one of the founders of ARIIX and chief sales officer, who, while living in China, encountered increasing air pollution and decided to pursue an air purification system, which grew into what we now have as the Puritii air system. So we'll start there. The Puritii air system is, I've included this diagram here, and you can find this on puritii.com. But the Puritii air system, one of the things that makes it unique is it includes an 11-stage filtration process. Many air filters out there have a multi-stage process, but there aren't that many that have as many stages or have these same stages. So you can see here we have the first 3 stages are in the pre-filter. We have the polymesh And then we have a couple of different filtration media, the ARIIX 15 and ARIIX 10, which will reduce particulate or screen out particulates of 15 microns and 10 microns respectively. And then we go to the main filter, and I'd just like to add the three-stage pre-filter is washable. The main filter, however, is not washable because it contains components that would be affected by water, primarily among them the potassium permanganate, which we'll get to. But so we have the 7-stage main filter, then has another stage of ARIIX 10, then it has a HEPA type medium, and a pre-volatile organic carbon diffuser medium. Then it has a stage of activated carbon, zeolite, and potassium permanganate. Now, potassium permanganate is a nice little chemical that is used in a lot of organic chemistry reactions because it is a very strong oxidizer. So it actually is used in the Purity air filter to react with and decompose any volatile organic carbon or volatile organic compounds. So we have solvents, so we have methanol or formaldehyde, any of these residues that may be present would be oxidized by the potassium permanganate, and that'll actually convert those to harmless carbon dioxide and water. So therefore, they're no longer volatile organic compounds. They've been oxidized by this component here. And then we have this diffuser to further diffuse those decomposition products. And then the last stage is an ionization needle, which produces a very, very, very low amount of ozone. And we're talking less than 1 part per million. I know we get a lot of questions about that. This is not an ozone generator per se, but it's an ionizing needle, and really what it does is it also diffuses some ozone in the filter so that any particulates will clump up so that they can be filtered out. So it's a filtration assist ionizing needle, not an ozone generator like you can find on the market. So looking at what this filtration system is made of, now let's look at what it can do. So we've got so just here I have listed some attributes. I'm going to change my screen to, I'm going to go to our, let's see, I'm going to go to our air filtration white paper. And so can you see that, Lee?
Yes, I can.
Okay, great. So I'm just going to scroll down so we can look at the actual results. So we want to look at what does this deliver in terms of clean air delivery rate, energy usage, sound, negative ions. I will send this to you, Lee, this document, well, all of the documents that we'll go over today, and then that way you can send them out to the participants. And then if anybody has any questions, I can be reached at quality@ariix.com. We'll put that in the chat as well. But that way, if you have any questions, please feel free to contact me. But just to go over these data, we see here the different airflow cubic feet per minute or cubic meters per hour are the two metrics we used on the different settings, and then we can also juxtapose that with the noise per setting and the energy usage per setting. So we can see what the most economical way to use this filter would be, and then also base it on your room size. If you need to move more air in a faster amount of time, then you can see how much that's going to cost in energy, what that's going to be in noise versus running it on a lower setting. So you can really customize your experience here with that. We see we also had a test done to compare the turbo versus the high to see what our maximum gains would be in terms of clean air delivery rate in cubic feet per minute or cubic meters per hour on these two settings. Those are the two most commonly used settings in our experience. We see also the ionizer produces here at a certain at these distances, at the 5, 10, and 100 centimeters, the amount of negative ions detectable from this ionization needle is very low. We see at 1 meter very low levels of particles. And then we see in the next criterion, we're at 12 hours of usage, we're still less than 100th of a part per million ozone concentration. And so there's no cause for concern of the ozone generated by this ionization needle. It's really just to improve the function of the filtration system, but doesn't generate any ambient ozone, or really any appreciable ambient ozone. And then now we're getting into the fun part as far as what does the filter remove. So we look at the metrics in particle filtration. We have PM 2.5 is one of the industry standards, and that is removal of particles that measure 2.5 microns in their longest dimension. So we see at these different speeds, we see the efficiency at the low and medium. We have 99.95% efficiency in removing, and that was done by measuring the particles and the ambient particles versus the particles PM 2.5 at the filter exhaust. And then we see just a very slight decrease in efficiency as the speed increases, but we're still in excess of 99%. Here at 99.86 and 99.88% at high and turbo. So the still, even with the maximum air moving, we still see very efficient, very high levels of particle filtration on this PM 2.5 metric. And then we have here, we see the curve of reduction of these particle contaminants over time. So a lot of really good, I think it's very exciting visuals, at least for those who find this sort of thing exciting, like myself. So it this we tried to include as many tests as possible, and these tests were done in a combination of places. We had some testing in Europe, some testing in North America, and some in Asia. And so this is a combination of all of those different results. We also did, in addition to the PM 2.5, we did PM 0.1 to 0.3 range, which is then 0.1 to 0.3 microns at longest dimension for the particles. And we see actually here in an hour, we have a functional total removal of these particle contaminants down to, so we can't say 100% efficiency, because just scientifically that's not really a valid statement, but we can say greater than 99.99% reduction. And at 60 minutes, we had the test revealed no detectable particles after running this in this particular test. We also did a 0.1 micron only. This is one that is currently quite relevant. We get a lot of questions about this particular test because the shall we say, we have some certain biological concerns in the world today that are rather popular that would fall in this range of 0.1 microns. I was just asked about a famous virus, and we'll call it that, yesterday by some customers from France asking about size, and that particular virus measures 0.12 to 0.16 microns in diameter, and our testing shows that the 0.1 micron range, we see in under 25 minutes, 99.99% reduction of airborne particles. So this is, while we can't specifically make claims about virus reduction because these weren't included in our testing, as you'll see in a second, the biological testing included bacteria and fungi, but did not include viruses. But we can at least be confident in the reduction of particle size. And moving to the biological contamination removal, we see using mold Aspergillus niger, which is a common laboratory standard, but is also a mold which in nature can cause certain health problems. We see in 120 minutes, our testing showed 99.9% reduction here. And then another test using the same genus Aspergillus, we saw a 99.99% reduction. So again, it depends on the parameters of the test, and that's why we've maximized the number of tests and the different labs performing them so that we can get the best possible data for the capability of this instrument. After this, we see that based on particle size, when you're dealing with a PM 0.1 micron, you've essentially captured all biological contaminants in that range, and so we can confidently remove biological contaminants from the air because they all fall in the particle ranges that we've already demonstrated capability to remove. When we look at chemical contaminants, these are not they're not larger particles, and kind of funny to say bacteria are a large particle, but relatively speaking, compared to a, a molecule of a chemical contaminant, the bacteria are huge. And so we look at these organic compounds, these solvents. We have benzene, toluene, formaldehyde, and so we're looking at very, very, very small molecules that we can look at in terms of filtration, but we also want to factor in the decomposition by potassium permanganate and the micropore sequestration of zeolite. Zeolite functions on two principles, and one of them is that it has very small pores in the crystal structure that trap contaminants and will hold them there. And so then they'll get stuck in these small microcapillaries, and then the potassium permanganate will break them down and in terms of these chemical contaminants. So we've got multiple modes of action to remove these from the air, and we have these. Then we can show in 40 minutes functional removal of all benzene. In 60 minutes, the toluene is almost completely removed, greater than 99% reduction. Formaldehyde is a very small molecule that it's hard to trap because of its size, but we can see that even in this test was run out to 390 minutes to get greater than 95% reduction. But if we look at even at 60 minutes, we're at greater than 70%, and 120 minutes, we're approximately 80% reduction. So even this small formaldehyde, which is probably the smallest solvent molecule we could be dealing with, we see very good reduction of this over time based on this particular capability. And then looking at total VOCs, we see in 40 minutes we've exceeded that 80%, and we get, after 120, exceeding 95%. So these tests demonstrate that the Puritii air filtration system is quite capable of removing physical, biological, and chemical contaminants from the air, and is also the system is certified by the Hong Kong Testing and Standards Center for basically to show that it complies with European standards, which are some of the strictest standards, and then also that it complies with China quality standards. The California Air Resources Board has certified this. This CARB doesn't focus so much on performance of the unit, but on energy usage, and therefore they're dealing more with the first attributes that we talked about. But still, they're saying that it's an efficient system to use for the energy invested. I'd also like to point out there are quite a few questions that we've received lately in terms of how this would classify based on HEPA filtration standards. So we've included in this white paper an appendix discussing these air filtration standards that are in use in the industry. So we have HEPA values, and this is based on the European HEPA standards, and also a MERV rating chart, which is commonly used in the U.S., but other areas will use that as well, and that's more for in terms of industrial heating, ventilation, and air conditioning, the MERV rating. But we just want to compare how this filter would stack up, so how you could explain it as what standard does it meet. And so based on terms of filtration efficiency, because our testing went out to the second decimal place rather than the third, we can say that it meets a H13 HEPA filtration. We see the 14 takes out to a third decimal place, and our testing only went out to 2. But we can see also that it does. We have seen very high efficiency removal of contaminants there. And we'd also say that this would meet a MERV 17 or above, which generally speaking, the MERV 17 and above and HEPA are considered equivalent. But that way we can just look at where it stands in terms of air filtration standards. So that is our Puritii air filtration system. And I think we'll hold some questions till the end, but I'd just like to move on to go over the Puritii water filtration system now. And I will switch over to the presentation for a moment, and then we'll go to the white paper on water testing. So the Puritii water filtration system is composed of, you can see here, again, this is from puritii.com, so you can look at it in greater detail, but it is set up it also has a multi-stage filtration system that includes within the polymer housing, it includes a pleat pack. This is what we generally call this, refer to it as a pleated medium or the pleat pack, which is actually a combination of polymer and mineral based media that includes it includes application of silver so that it will be antimicrobial, so you don't have to worry about bacteria growing in your filter. But the pleated medium, the pleat pack, is designed specifically to filter out biological contaminants. And then within the pleat pack is housed the granular media, which is a combination of activated carbon and zeolite, which we have also in the air filtration system. The activated carbon and zeolite provide an excellent combination of filtration media for water filtration because of the micropore structure, micropores present in the structures of the activated carbon and the zeolite. They will absorb contaminants from the surrounding water, and then they will trap them. Activated carbon is excellent for removing organic compounds such as solvents, other compounds like pesticides or pharmaceutical residues are also absorbed by activated carbon, and zeolite is excellent for removing minerals such as heavy metals. Activated carbon will also remove lead, so the zeolite and the activated carbon will both remove lead from the water should it be present. But they work hand in hand to focus on both the organic and inorganic chemical compounds. So we'll look at some of those as we go to the testing data. So we'll go over to here, and so we'll see, scrolling down these. So then in this white paper, we discuss then what tests were performed and by whom. We commissioned testing by 2 labs, one that is located in Florida, and the other, if I recall correctly, is located in Canada. And the first lab is one of the gold standard labs for water filtration testing, at least in North America. They do a lot of testing for government agencies as well as industry. And we had them test most of these tests for us. And then the second lab performed testing on some emerging contaminant issues. But we look at biological contaminants. So we were concerned about bacteria, viruses, and then also parasites of protozoa, such as Giardia or other amoebas, other non-bacteria, non-virus microbiological contaminants. And so we had tested here, we used a model bacterium, Rauwoltella terrigina, which is used as an analog here to look at general waterborne contaminants like Pseudomonas, like E. coli, like Klebsiella. The Rauwoltella is non-pathogenic, so it was safer for the lab staff to use this organism, but it's the same size and very similar biochemical properties as these other pathogenic bacteria. And so we get almost complete reduction here, 99.9999% reduction from the Purity water filtration system of this microorganism. We look at, for virus testing, we used a bacteriophage, which these viruses infect only bacteria, so it's also a safe model to use for the lab staff, but it also serves as a good analog for infectious viruses that would infect humans. And we see also a 99.95% reduction in virus particles by this filter. And again, these are around that 0.1 micron range. For the parasites or the protozoa model, we used actually an analog, we used a fluorescent microsphere that's the same size as the protozoa, these microorganisms in question, and we saw a 99.997% reduction in these microspheres. So again, this showing that the Purity water filtration system is very capable of removing microbiological contaminants from water. There's a story that we tend to share about this. At least when I'm asked, we had a member of our R&D team who was previously with the company. He's since left about a year and a half ago, but he went on a service trip to Nepal to build a clinic with a group of military servicemen. They went to the Kathmandu River Valley to build some clinic for the people there, and the Kathmandu River Valley is notorious for its contamination, biological and chemical contamination. And this group, the year previous to when our former colleague went with them, had all gotten sick from drinking the water in the area. And so then the following year, when they invited him to accompany them, he took Purity water filters for the team, and it was probably about 10 individuals, and made sure that they all drank their water from the Purity system and nobody got sick. So it's an anecdotal evidence, but at the same time, it shows a real world application here for the Purity water system in terms of microbiological risks and its effectiveness against them. Moving on to chemical contamination, we see, so looking at inorganic chemicals, so here we're looking at primarily minerals, but then some other inorganic compounds. We see against arsenic, hexavalent chromium, lead, copper, and mercury. We see very good filtration here. The arsenic, lead, and copper and mercury all high 90% reduction. The hexavalent chromium is a little different because it is a smaller mineral, but also it's a very positive, in terms of electrochemically charged mineral. It's this ion is very positive, and so that actually results in it doesn't attached to the zeolite matrix as well as some of these other chemicals because of the net positive charge that the zeolite has, or sorry, as a net negative charge in the zeolite, but it's got different affinities for different compounds, and so other compounds will attach to the zeolite instead of the hexavalent chromium. So we still see approximately 60% reduction here, and which is still, given the substance, quite an effective reduction in this analyte. These next two, we look at nitrates and fluoride, are also very small and very water soluble. In the case of nitrates, all nitrate compounds are soluble in water, and so therefore it's more difficult to remove that. It's not going to be trapped in the zeolite to the same extent as these other compounds, but there is still some removal. And if there is a concern for nitrate contamination, it's possible to do a multi-stage purity. It's I've had that question before, and so multiple filtrations of the same water would then remove those contaminants, provide greater removal there. This is just based on a single pass reduction of these compounds by the filter. When looking at organic compounds, we see using pesticide models and volatile organic compound models, we see very high reductions here, greater than 95% on all pesticides tested. And then also the solvents, we have greater than 90% on most of them, with the exception of acetone and chloroform, which are small, very small molecules. And also we deal with water solubility issues and just the simple size of the molecule. Therefore, it's not as likely to be trapped as solidly as some of these other compounds in the filtration media, but it achieves a filtration nevertheless. We're also looking at emerging contaminants as opposed to our standard that we typically historically think of with water filtration of inorganic, organic compounds and pesticides, pesticides and solvents. Now we're looking at we have free chlorine. We see the greater than 97, almost 98% reduction in free chlorine. Looking at bisphenol A, or BPA, which is an emerging contaminant, a plasticizer compound. We see that the Purity water filter will remove 99.5% of that based on these tests. And then we have esterone and ibuprofen. So we've got a hormone and a non-steroidal anti-inflammatory drug. So we look at these as analogs for pharmaceutical residues in water, which are emerging contaminants, and we see a very high reduction in those from this Purity water filter. And this next round of results is another grouping of emerging contaminants. They're called per and polyfluoroalkyl substances. They're generally industrial related, and we see that in most cases we see significant removal of these. So much like the BPA, these are similar to the BPA in that they are industrial compounds. A lot of times they're introduced in water systems by unscrupulous industry practices, and so therefore they are more and more in the news lately. And so these tests showed multiple rounds of testing and showed how many of 6 samples after filtration, how many were undetected versus how many had trace detection of these compounds. And so in the majority of cases, we see complete removal or just trace detection here. So the Purity water filtration system will remove these PFAS, or the per and polyfluoroalkyl substances. So we can take that for industrial contamination. We can look at it for pharmaceutical, for pesticides, solvents, minerals, biological contamination. In general, this is a very versatile filtration system for essentially any use that you may encounter. We'll go back to the presentation now for a moment. So our third Purity product of discussion today is the Purity Home Detox, and I will, if I can get there we go. So we have So Purity Home Detox is a new product that we've just launched in the last, I want to say, 6 months. And this product is a very simple formula, but it's very effective. It is a combination of there's really three active ingredients in it. That it has chlorine dioxide, which is essentially harmless for us, but it very handily destroys microorganisms. It's an oxidizing compound, and then also it includes two quaternary ammonium compounds, and in very low levels. And this combination at these very low levels proves very effective at destroying microbiological contaminants. We have bacteria testing, virus testing, fungi, protozoa, and in all cases, we achieved disinfection in 5 to 10 minutes of contact time. Also, because of the active ingredients in it being what they are and at the levels that they are, this is a no rinse or decontamination product. So you don't have to. There's no dangerous residues after use on surfaces, so there's no need to rinse after applying this disinfectant. And for use as a food contact surface, our testing showed 99.999% reduction in 60 seconds, which is when in terms of food safety, that 5 log reduction is generally a benchmark that you want to meet to consider something sanitized. And so we see that effective reduction in just 60 seconds after application. And our testing include a battery of all of these different organism types, and we will have a white paper coming out explaining these. Because of the newness of this product, we don't yet have that white paper available, but as soon as it is available, it will be sent out so that way everybody can have a copy of those results in hand. The last product, and just so we can cover all of the Purity products, is the Purity laundry detergent, which is based on a blend of detergent and enzymes to remove food stains or other stains in clothing. This product is launching first in Japan. It was developed essentially by request of our Japanese market, and then availability in other markets is to be determined. And then we'll have additional information forthcoming as we gather all of our testing on this particular formula. But we're very excited to have this as an additional product in our Purity line. That way we're building the Purity line in the sense not just to remove contamination, but for overall cleanliness. But unfortunately don't have as much information on this as I would like, but this is cutting edge information right now. And that's all I had to present on the Purity products line. So thank you for involving me today, and I'm happy to take any questions if the time permits, Lee.
Yeah, we still got some time. I've got a question, and it's just something that I saw on one of the videos in the ARIIX training library. It's the first time that somebody uses the water purification system. There's like a gray dust that comes out. You just want to explain that, because I'm sure that a lot of people will ask that question: what is coming out when you use my bottle for the first time? You just want to talk us through that?
Yes. So there is when when a new filter is used, there is a gray dust that comes out with, or the water may look a little gray. That is a product of the activated carbon and zeolite, the granular media. So what it is we use a granular, a little bit, I guess we could say relatively larger granules of those media, because too fine of granules will result in too high of a surface area relative to the water passing through, and it makes the suction force necessary to draw water through it very, very high. And so we try to limit the fine material present in those granules, but inevitably there is a small amount of fine material, and so that's actually what passes through. Perfectly safe to consume that water. It in fact, it will just really help clean out your gastrointestinal system. It'll absorb anything there that that can be absorbed. It's very similar to the product in our Nutrify line. The ARIIX actually has a combination of activated carbon and zeolite for the purposes of cleansing your digestive tract. And so that those fine particles that you get from a new filter are the same active ingredients in the ARIIX. So they're, and it will clear up as the water is passed through that filter. It'll clear up, but there's no safety concern for that that gray dust in the water.
Well, that's good. So there's actually added benefit to having that. And then
Yes.
when do you know when to replace the filter?
So the filter is based on, we base the guidance on filter replacement on usage. So if you're drinking, the original guidance was to change about every 60 days. There's we have testing to show that the filter, what the filter is rated for, and it actually can go. If you're using relatively clean tap water, you can go longer than the 60 days. But if you're using any water of questionable source, questionable quality, questionable contamination levels, I would err on the side of caution. And for example, if I travel internationally, if I don't know where that water is coming from, I will change my filter. Or if I traveled, I recently, a couple years back, was serving as a Boy Scout leader in my local scout troop, and going to the scout camp up in the mountains, I took my Purity water filter because I wanted to have clean water. And so once I'd used it on, even though it was a relatively clear mountain stream, once I got back to where I had safe water, I changed out and had a new filter. I changed it out just because you don't want to overload your filter. But in general, if you go 60 days, you should be fine.
Okay, awesome. Thank you, Jeff. We've got a question from Mona just regarding the stock of the water purification bottles. I don't know if you're the right person to answer that. Do we know when there will be stock available?
I do hear a little bit of because I work with all the departments in the company. I do hear a little bit here and there. I know we do have orders in. I unfortunately don't have time for the ETA on that, but I'd be happy to reach out to the operations team. Our normal operations meeting is going on right now, and so I won't be able to talk to them today, but I will reach out to my counterparts in operations and find out an ETA, and then I can send that to you.
That would be great. Thank you. And I will just communicate it with everybody. I don't know if there's any other questions. Thank you, Jeff, for this really in-depth training. We have.
You're most welcome. Thank you for having me.
Yeah, we've got a few people that can't make it to the call because of the timing, but I will be sharing the recording with everybody. So, and they will be very excited about this information. I know of one of our Swedish leaders who already bought the air purification system as to try out for the Swedish team and give them feedback. So we're all very excited about these products. Thank you very much for your time. We really appreciate it, and have a wonderful day further. Thank you everybody for joining this call. It will be available in the YouTube channel within the next half hour or so. I will also share it on the WhatsApp group. So thank you for joining. Please join us tomorrow again for more product training. Bye-bye, everybody.